So if you looked on the schedule for TypeScript Seattle, there's actually going to be map types, conditional types, and maybe some other thing. But now it's only going to be mapped types because I want to describe them really well. You guys are going to know so much about map types that you guys will be able to give this talk when it's over. So who am I? I'm Tyler Wolf Leonhardt. I'm a former video game developer at Microsoft. I'm now working on an operating system for the cloud, and you can check that out at strat.world. I'd recommend visiting that if you're interested. And you could find information from this talk on this GitHub link. You'll be able to find this information through the TypeScript Seattle Meetup. I believe they have a link to a video on some of the PowerPoints. I've actually got one question for the audience because I saw this interesting thing when I was looking through the attendance. Is there a Tyler Leonhardt here besides me? There's another Tyler Leonhardt signed up, and I was hoping to run into him.
He keeps RSVPing, but I still haven't.
He keeps doing it, yeah. So what is a map type? A map type just takes properties in an existing type, and it maps them to properties in a new type. So all that means is if you've got an interface like this one, iSizes, you've got a bunch of properties in it, and they have a bunch of types. A map type could turn it into something like string sizes on the right side. It could have all the same keys, but have different types for them. So in this case, it turned all the numbers in iSizes into strings in iString sizes. And there's a special syntax for that. It looks like this thing in the top right here. So these are always generic types. So you'll see these, I call them chevrons. Some people call them angle brackets with a T between them. And what this says is take all of the keys in T and map them to strings. So that would be taking the stuff on the previous side over here, these keys, and then mapping them to strings. And you can use the map type like this on the second line. So we would use props to string, and we would put the type we're converting between the chevrons, and that would give us our string sizes. To hammer that point, these are the same types. In other words, if you've got two variables, and one of them is iString sizes with everything explicitly declared, and one of them is string sizes using the mapped type, you'll be able to assign them to each other and use them where the other could be used. So they are completely identical. Another way of thinking about this, and I think for beginners this might be one of the best ways of thinking about it, is that for a regular type, all your keys are going to be in this box in red, and the types, the things in the green box, are what's going to get replaced by the green box on the right hand of this slide. So in this case, again, strings are going to replace all of these numbers. Now, I taught you all that, but what's it good for anyways? Just a bunch of characters on the screen at this point. So map types are really good when you've got a bunch of types and they all need to have the same keys, but they have different value types. So if you were going to do that without map types, you need to take your type and paste it and paste it and paste it and go through all of the different types you pasted and change them to whatever it was you wanted. They can also be used to build partially self-referential types, which we'll discuss later on in this PowerPoint. And we're going to use them to build a theme library for a Space Camp sign-up page, and there will be a live demo at the end. So here's a sneak peek of what that code is going to look like in the final product. We are going to have what I'm going to call raw colors or base colors. I would also refer to this as like a theme resource. And then they are going to get mapped to more general names for what they're going to be used in the application. So when we're putting our colors into the app, we don't want to say red for button and green for background. We just want to use the term primary foreground, primary background, and so on. And these are going to reference types in the raw colors. So this way, in your application, you'll be able to say things like theme.colors.primary foreground, and that will give you the red color. You won't actually have to say red. And what this means is if you went in and you changed the primary foreground color to something else, you wouldn't have to like control F through your app and like replace where red was everywhere. You could just change the primary foreground color and it's going to automatically update everywhere. Another neat way you can use this is at the top. You can use it with the bracket notation. And if you use it that way, you can actually pass in an override. So this is going to generate some CSS for a button, and it's going to have a default background of the button background color. But if you wanted to like explicitly say that's going to be red or blue, or maybe it needs to be the same color as the input color for some reason, you could pass in another color and override it. And I actually do use a theme library very similar to this in my own applications. So let's build it. We're going to get started, and the way I usually start out building these more complex types is I think about how I'm going to use it. So I had that example back here, and then I'll kind of just put it in my code editor without any of the type information at all, kind of like the finished product. So right now we've just kind of got some raw colors, and they're all just strings. And we've got our reference colors, which are going to reference the raw colors. But there's problems doing this. You don't get any of the type checking. So we can go into this example. I'm going to open up VS Code over here. You could basically be editing these colors, and you could enter anything. So if you had some sort of like typo in here, you're not going to get any protection against that. And if you went down here and you wanted to reference a color that didn't exist, like black, that's going to be fine, and the editor is just going to let you do it, and the app is going to end up crashing when it runs. So we don't think that's very good. We think we could do better. So to start improving this, we're going to assume we've got this interface right here. I'm only putting this on its own slide because I don't want to paste it on every slide. All it is a color that's represented by a red and a green and a blue. And that's going to take care of doing the type checking for our colors right here. So instead of defining them as strings, we're going to start defining them with objects. This will help us make sure that we don't have anything in there that shouldn't be in there. So in the previous example, you were able to enter some text in that string that wasn't really a color. Well, now the things that are there are definitely going to be colors because that's what their type is. And then we're also going to add some more types in other locations. So we've got an interface now for all of our raw colors. So this object now has to match up with that interface. And we're going to have another interface for all of our reference colors right here. So now our reference colors have to match up with that interface. So we're a little bit safer now, but we've created new problems. And the new problems are that if we want to add a new color down here, we're going to have to paste it in two places. So if we wanted to add yellow, we'd have to add it to our interface and to our raw colors. And same thing if we wanted to add a new reference color, we'd have to update this interface and the colors down here. We can't just update one of them. It also doesn't solve the problem of entering an invalid string down here. So we can still enter reference colors that don't actually exist in our raw colors. So we're going to fix up one of those problems right now. We're going to use this operator. So we're going to change the lines right here. And what this says is that the things that appear in iColors have to be keys that appear in iRawColors. So I'll show you what this means in practice. I'm going to get VS Code opened up again. So here it is. So here it is with the keyof operator. And if I try to enter something which doesn't exist in our raw colors, so I'm just going to try to change this blue to yellow, you'll see we get an error. Yellow is unassignable to red, green, or blue. So that's nice now. We can't enter colors that don't exist. So that kind of fixed up one of our problems. But again, we still have the problems of having to update both the things at the top if we want to add a new raw color or a new reference color. So we're going to try to make things even better. We're going to try to not update things in two places. And we're going to fix the problem by using a map, a regular map. So the lines we changed are up at the top. These are the only ones we changed. And instead of saying raw colors is a set of these three colors, we're going to say maybe any string key which has a type of color. So all of this code still works, but we've actually broken something. We no longer have to update the raw colors in both places, but the I colors at the bottom, the reference colors, will no longer work. So again, if we go back to VS Code, I'll show you what I mean in the editor. So this is attempt 3. When we say key of raw colors, now that raw colors is a map, its keys can be anything. So iColors doesn't know what these types are supposed to be. It's just going to assume that they could be any string. So once again, we could type yellow in here. And even though yellow doesn't exist in raw colors, we could run this app, and then when it started to run, it would crash or the color wouldn't show up, or we would get some other sort of error. So if you tried to work with that for a while, if you tried to fix the problem, just kind of modifying this example, you would find that you really can't make much progress on it. We took a wrong step. And I would say this happens a lot when you're kind of fiddling around with types. So again, what we're trying to do is start with something simple and then work towards something advanced. And just like doing a math problem, you might go down the wrong path, and you might have to kind of rewind and work backwards and take a step in a different direction. So we're going to go back a little bit. We're going to remove the key operator over here. So the keyof is gone. We're going back to iteration 2. And then we're going to take this step back and try to continue working from there. I'd say this is a real thing that happens at work, and especially if you're like trying to mess with types, trying to get something to be perfect, you can spend quite a lot of time trying to get things set up exactly how you want. If you're working with something like this, sometimes I almost want to say like given up and replace things with any, and I'm like, okay, well, I'll learn more about this problem and come back to it, and eventually I'll have the types correctly. But that's how I've dealt with these sorts of problems. So instead of using a map like we did before, we're actually going to use a mapped type. And that's going to come in up here. And this is one of the mapped types that I described as self-referential. So this is a little bit special. It's going to take a type parameter t, and then it's going to say all of the things inside of that t are colors. So it's very similar to what we had before with the string setup. It's just instead of saying that the indexers are strings, we're going to say that they're keys in T. And with this construct and this little function here, which I'll describe in a second, we can define our raw colors such that they are all this color object, but without having to constantly update the type. In other words, we could do what we wanted. We could add our color just in one place and know that it is a correct color. I'll describe why we need the function in VS Code. So I'm opening VS Code up right now. So the problem with just using the type, let's do this without the function. If we just tried to do the type, so I'm going to add a type annotation here. This is called raw colors. And an equal sign. We have to put something between these chevrons to use the generic type. And then you start to wonder, well, I can't put anything there because my type is defined right here. And if I try to define this type before it's used, you end up in the same problem we had originally, which is that you're going to have to copy and paste everything in two spots if you want it to work. So if you did want to put a type, the closest you could get is by copying all this stuff and then pasting it between the chevrons. But then you're not really any better off because now you've got all your stuff in two places. So you could kind of take advantage of the compiler and you can pass your object in. So it's going to get passed into this function as this parameter. And then the compiler is going to look at this and it's going to be like, okay, it's supposed to be a T. And then that T is going to automatically be used as the type parameter. The type parameter has this constraint which says it has to be raw colors. And raw colors is going to guarantee that the keys are all colors. So all that means is if we tried to add something else in here and it wasn't a color, it's not going to work. But we could fix our previous problem and we could actually add as many colors as we want, and you'll see you don't get a squiggly red underline there. So that's a pattern I actually use a lot to do these sort of map type constraints, and I think it's really pretty useful. And then we're going to tidy up one last thing, which is that these colors on the bottom still have to be pasted in 2 places. And we're going to fix that up right now. I'm going to get rid of this part at the top. It's just going to go off screen just because I can't fit all that code. And this is the mapped type that we're going to use to describe the reference colors at the bottom. So it's pretty similar, but it takes 2 type parameters. It now takes a T and it takes a T raw colors. And it has to take 2 parameters because we want to say that the types of the reference colors are keys that appear in the raw colors. So this keyof is going to be a key of T raw colors. We're going to pass raw colors in as T raw colors, and it's going to guarantee that the key exists in this guy. And then, just like before, we have a function. This is also going to handle another problem that I didn't mention previously, which is that these colors actually have to be compiled into that RGB string if we want to use them in HTML. So I've got some parentheses on the far right with a comment. I just kind of made that magic disappear. If you're interested in it, I'm not going to go through this whole function, but this is what it is. The gist of it is it's going to iterate through all the colors, and then it's going to interpolate and create a string key for them. So that's what I mean by compiling them. It's just going to iterate through them all and turn them into strings so that they could actually be used in themes. You guys want to see a demo? All right. So getting the demo up right now. So the demo's in VS Code. I'm going to show you what the demo looks like first. Well, I guess I'll start with the code, and then you can kind of like imagine it in your head, and you can try to figure out if you were right or not. So we're going to have a React page, and this is going to, too small? I'll make it a little bit bigger. I'm going to change it to a light theme too, because I think it'll be easier for people to read. All right. Is it still too small? Does anybody want it bigger? Is that good? Close all my panels. All right. Is that good? I hope that's good. That's as big as I think I could get it. Anyways, these are CSS definitions. So this is going to be a React app. So this is where I've got all my divs and labels and stuff. And you'll see all the styles right here. That's where I'm going to have the CSS. And this is just going to call functions up here that kind of return the CSS object. That's what this React.css properties is. And for each of these, I'm going to pass in that theme object that I talked about. I souped this one up a little bit so that it's got more stuff in it. This one works with colors and fonts and text, and you can actually extend it to work with any sort of object. So this would be good for localization, like you could have a theme for English, French, and then the text would change depending on your language. It could also be used for images if you wanted to change an image. It's super generic, and it has some error handling built in. Anyways, this just gets used by calling whatever sort of resource you want, a color in this case, dot whatever the resource name is. So colors.input background for the background color of our input, colors.primary foreground for the foreground of our input, and then a bunch of other stuff like that. I've got one for margins, for fonts. Basically all those themes are extensible. And then the way the theme actually gets set up is very similar to what I showed you guys in my slideshow, we've got a bunch of raw colors. So we're going to have 3 themes here. We're going to have space, we're going to have unicorn, and we're going to have dinosaur. So these are all the raw colors we would need to present any of those themes. And then this would be a single theme. So this is going to be the space theme. And we're going to map a primary foreground color to a light gray, a primary background to a dark gray, and then map a bunch of other colors. We're going to map fonts for our space theme. We're going to map numbers, and we're going to do some strings. And then below that, and these are the raw strings for all the different themes. And then below that, we're going to have our unicorn theme. So I've got this extra function, theme based on. So this unicorn theme is going to be based on the colors from the space theme. And we're going to override them. So we're going to override the primary foreground color. And the kind of neat thing about this is if you were building this, so like let's say we don't have this input background, you get pretty good IntelliSense. So this is going to be an error, or maybe not. Uh-oh, maybe it's not an error. It's at least an underline. I'm pretty sure it won't compile though, so I'm going to try to compile this right now. I could be wrong about this. I might have some sort of error in my theme based on. Oh man, it did compile. Okay, there's a little bit of bugginess there. But anyways, I'll show you the gist of it. It still works. We might not get error checking. I might have broken something while I was tweaking the details of my presentation. But anyways, this will take all the colors in that original theme, and then we'll be able to remap some to different things. We're going to remap some of the grays to different sorts of pink, light gray over pink, and so on. We do the same thing with strings down here. So we have different strings for buttons. Seeing if I get IntelliSense of any sort. And then same thing for the dinosaur theme. We just map a bunch of different resources. And that's basically it. Now we've got 3 themes. But most of them are based on that original space theme. If I hit F5, you'll see what the app looks like. All right, so here's the app. It's pretty simple. You just add your first name, last name, address, and your favorite planet. And if we click the switch theme button, we'll get our unicorn theme. So all it did is in React, it set state with the second theme, and then all that CSS updated. And now we have some new strings. So instead of launch, we've got ride and dismount. And if we go to the dinosaur theme, we've got roar and hide buttons and a box for your favorite dinosaur now in all different colors. And that's the demo. I hope you enjoyed map types in TypeScript. Questions? How does the mapped type know?
Yeah.
So I'm going to move over here so I could answer it. So it knows what it's going to be by what you put on this side. So this thing right here is the mapped type. And then what you have over here is the new type of all the properties. And then the way that gets used is like this. So on the far right side, you're saying sizes. So this bit, the first half of this, knows to look up things that are in here and then replace all the types of strings. Is that making sense? Or?
Key value pairs in it.
Oh, yeah. So this might be helpful. This came in on, I'd say, one of the more complicated slides. So this is a mapped type with 2 type parameters. So we're going to say this T here is the thing that's going to get mapped. So he's going to have all of his properties replaced. And the thing that they're going to get replaced with are keys of the second type. So if you passed in 2 types, I'll kind of show you. I'll show you in VS Code. We might be able to get something together that answers this question. So for this one, you're going to be passing in two things. You could just pass in that and raw colors. Okay, cool. So this function here, this colors function, is basically going to, you can sort of imagine it as generating a type that looks like this. The second parameter is going to be the type of this guy. So if we look up here, this second parameter is going to have his keys taken and applied as the types of this T. I don't know if this makes it more explicit to you how that's happening. We're just passing this thing in. So because it's the type of raw colors, it is going to be the keys of T raw colors. And then those keys are right here. So again, the keys are associated with raw colors. Raw colors is getting passed into regular colors. And then the thing in regular colors is going to have his keys taken. So that's kind of like the chain of logic that's flowing to map all the types. I don't know if that explains it a little bit better.
A little bit. I think that's starting.
Okay. So they're super useful when they're used with conditional types, but sorry. So this is like one use of mapped types. What are some other uses of mapped types? And they're super useful when they're used with conditional types, but I was forming this presentation as a more basic presentation. I was trying not to introduce a whole bunch of advanced types into it, so I stayed away from conditional ones. But with conditional types, you could like selectively replace keys. So that is another great use of them, and I would say that's like one of my more intensive uses of them. I actually use them a lot in this sort of constraint pattern I showed you, because it's a good way to constrain a type without like defining it before. But that's probably an even bigger one. I just didn't want to go into conditional types in this presentation.
Yeah, I saw right?
Right, yeah. In fact, I actually, for this theme library, I initially had it set up as an enum and then all the colors below it. But then I kind of ran into the problem of like having to define things twice, because I would have like the enum name, and then I would have the enum name again and what color it actually was, and then I'd have another enum for what colors it was getting mapped to. So it was like I had that problem of typing in two things twice. I really went to the map types just so I had to type it in once, and it works nicer defining multiple themes and stuff. So I know it. Yeah, I do know exactly what you're talking about. I think I fiddled with it a bit, and I think there was some aspect of it that I couldn't get working correctly. I'm trying to remember what that was. I think as const made it like so like if we did this bottom type as const, like this is the sort of thing I actually want to be generic. If I make this as const, the type is going to be primary foreground color is red rather than primary foreground color is string. And that would get a bit strange when I started to add new themes, because I'd want to have the unicorn theme, but this wouldn't be like key of raw colors. It would be red. So then you kind of start to get other type checking errors. You might be able to work around that somehow. Like maybe you could move the type of operator somewhere else. But one, like I was creating the project with the mindset of demonstrating map types. And then two, I did run into a few snags trying to do that. And it was the sort of thing I mentioned earlier where it's like you could really try to get your types perfect and terse and concise and everything. But then you're like looking at types for like 3 hours and you're like, man, I got a presentation to make and I got to figure out what I'm going to say. So maybe I'll just cut it off here. Anything else? All right. Thank you, guys.